Okay, example 3. All edges of a cube are expanding at a rate of 3 centimeters per second. How fast is the volume changing when each edge is 10 centimeters? Okay, so we've got the no. So what formulas might apply with this? So how fast is the what? The volume. And it's the volume of a cube. So a cube, length times width times height, and they're all the same, so you can just have it as x to the third. You could have it as h to the third, whatever variable you want, just just pick one and go for it. Don't choose another v. Okay, let's see what your givens are. So each edge is 10 centimeters, so we know x is 10. And they gave you something else. The edge is expanding at a rate of 3 centimeters per second. So the edge variable was x, so that's got to be dx dt, and it's 3. And then the find, what are we trying to find? How fast is the volume changing? So volume changing, dv dt. All right, so let's go back to your no equation, and we're going to take the derivative of that. So dv dt is equal to 3x squared times dx dt, and now we can start plugging in our givens. So the x is 10, dx dt is 3, so dv dt, if you start multiplying that out, that is 900. And again, they gave us units in the problem, so we need the units in the answer. So it's a volume, so centimeters to the third per second. I put the units in at the end of the problem, just so I don't, to me it looks messy if you stick them into here. You can do it if you want, but you don't need them until the end. Okay, let's go ahead and try some more. Okay, example 4, a ladder 17 feet long is leaning against the wall of a house, and the base of the ladder is being pulled away from the wall at a rate of 2 feet per second. This sounds like a prank. So A, how fast is the top of the ladder moving down the wall when its base is 8 feet from the wall? All right, let's go ahead and just sketch this out. Sometimes that helps just to visualize what's happening. So here's the wall, here's the ground, and here's the ladder. And we're assuming the wall and the ground are perpendicular. So here we have a right triangle. So the ladder, it's 17 feet, so it's a constant 17, but the height is always changing, as well as the base of the triangle. So we can't label them with numbers, you have to label them with variables. So let's make the base x and the height, just make it a y. You can use whatever letters you want. I just kind of stick with x and y if it's going left and right and up and down. Okay, so what formulas might apply, or what do you know that would go with this shape right here when you start talking about the lengths? Well, right triangles, I mean, there's a lot of stuff that applies with them, but probably the big one for this is just the Pythagorean theorem. So x squared plus y squared is equal to 17 squared, because it doesn't talk about the area at all, so don't choose the area. It didn't talk about an angle, so don't use a trig function. It's just talking about the sides. Okay, so what are we given? So we know the ladder is 17 feet, so that's already in there. The base of the ladder, so the base right here, is being pulled away at a rate of 2 feet per second. So the base is changing, so dx dt at a rate of 2. Okay, how fast is the top of the ladder moving down the wall when it's base, so when x is 8 feet, so x is 8. All right, and what do we want to find? How fast is the top of the ladder moving down the wall? So the top of the ladder is moving down the wall, so it's talking about the y. So how fast? That's a rate. So the rate of the y, so dy dt. So if I want the dy dt to just sort of magically appear, I got to do the derivative of the no equation. So the derivative of this, 2x times dx dt, plus the derivative of y squared would be 2y dy dt. And this is where students kind of start getting into a mode, and they kind of get locked into following a process or a pattern. And so they do the derivative of 17 squared, they pull the 2 down, and they keep going. Well, 17 squared, that's just a number, it's a constant. What's the derivative of any constant? Big ol' 0. All right, so let's start plugging in what we have and see if we can solve for dy dt. So we know that x is 8, the dx dt is 2, plus 2. Okay, we need y. Oh, they didn't give us y. Dang it. Well, hey, I can find it. Because I know x is 8, so I can just use Pythagorean theorem and get y. So y squared plus 8 squared is equal to 17 squared. So if you do the math on it, solve for y comes out to equal 15. So every once in a while, you're going to have a variable that they didn't provide, but you can always use the no equation to figure it out. And then once you get it, just plug it in. All right, so we have 32 plus 30 dy dt is equal to 0. So dy dt is going to equal a negative 16 over 15. And the units, since it's just a length, is just the same as the x. It's just feet per second. Feet per second. So let's look at this negative for a moment. Like, is that right? Can you actually have a negative rate? And the answer is yes, you can. You can have a negative rate. Just when it's negative, that means that variable is actually decreasing, which it is. The value of y, or the height, is going down, so it should have a negative rate. X is positive, the rate of x is positive because it's getting longer and longer as this base gets pulled further and further away from the wall. So don't panic if you end up with a negative rate. Just see if it makes sense to the problem. Okay, part B, find the rate at which the angle between the ladder and the wall. So we still have that same picture. But now there's another variable. The angle between the ladder and the wall. So here's the ladder, here's the wall, and here is the angle in between them. So when they start throwing in angles, the formulas that are going to go into the no category are probably going to be a trig function. So we need to choose a trig function, and any of them would really apply with this. So you can kind of choose your favorite. Personally, I like to go with a function whose derivative is positive, and then doesn't set up two variables in it. So let's go with sine of theta. So sine of theta would equal x over 17. Your givens, we still know x is equal to 8 from the previous part, and the dx dt is still equal to 2. But the find, I'm not finding the same thing anymore. Find the rate at which the angle is changing. Well, the angle is theta, so d theta dt. So that's what I'm looking for. So I'm going to go back to the no equation and start taking a derivative. So the derivative of sine is cosine. The derivative of the angle is d theta dt. And then for the x over 17 is the same thing as 1/17 x. So don't use the product or the quotient rule with this. Just do a derivative, just power rule. So 1/17 times dx dt. So I'm going to start plugging in what I have. So the dx dt was 2. Now the cosine of theta, I know all three sides when x is 8. So when x is equal to 8, the y was 15. So if I did cosine of this triangle using theta, cosine of theta would be 15/17. And then you can get the d theta dt by itself. So if you multiply by 17/15, you're left with 2/15 as the fraction. And then the units for angles, it's going to be radians. And then the time unit stays the same. So it stays the same as it was before, seconds. So radians per second. Okay, let's go ahead and stop the video here, and then we'll continue on with example 5 in the next one.